All right, everyone, welcome, as I mentioned, to Software Licensing Simplified. I'm Lauren Pafumi, and I'll be moderating your webinar today. We've got about an hour, so we'll get started quickly. We have Aaron Sowers, Kathleen McDonald, and Barry Datloff presenting today. And they've done a really good job at their own labs to make software work for their tech transfer programs. And today they're going to start helping you think about how to do that for yourselves. So if at any time during the webinar you have questions for any of them, just type them into the chat box you see in the webinar controls on your right. So Aaron, go ahead and get started.
Thanks, Lauren. So software licensing is obviously a very broad topic, and given the hour that we've been allotted, this session will be necessarily summary, but we hope to obtain your feedback, not only to inform further software webinars, but more importantly, to inform the upcoming software session at the FLC National Meeting in Chicago. If you haven't signed up for that already, I encourage you to do so as soon as possible. With that, let's jump right in. So today's roadmap, we're going to talk about, is it better to protect software through patents, copyrights, or something we call black boxing? How can things you're not traditionally allowed to patent give you value? What can you do at a GOCO that you can't at a GOGO, and vice versa? I think many of you know where we're going with that. And then the various software distribution models, their benefits and their concerns. And so what we're talking about there is commercial and proprietary licensing, non-commercial, open source software licensing, and software as a service, or SaaS.
So this is Barry Datloff from the U.S. Army Fort Detrick, Maryland. And I wanted to point out that things, both through natural evolution and the slower natural evolution of the government, have led us to the blue box here. Traditionally, patent, copyright, and trademark are classic tech transfer mechanisms. Code and data has been tossed in there as well, but now really the whole field is moving towards the cloud. And black box is something that we'll talk about in greater detail, but very much people are more used to going on their phone, getting stuff via an app store instead of the traditional methods. And ultimately, we want to help our licensees connect with us, not only through the software license process, but also some enhanced cloud-based activities such as communities of practice. Next.
Hi everyone, this is Kathleen McDonald from Los Alamos National Laboratory. Thanks for joining us. So as Aaron and Barry have already kicked off for us, one of the things we want to talk about today is the ways we can protect software and what are the best mechanisms to do it. And I think the critical thing to remember here is that in large part, this is very much governed by what you're allowed to do, of course, under your authorities that you have at each respective laboratory, and as well as by inertia. And I think you'll start to see what we mean by the inertia related to copyrightable materials, and particularly software, as you get further into this session. We're also going to talk about the differences between patent, copyright, trademark, and black box. So let's keep going.
Okay, so just to review, what is a copyright? Copyright is original works of authorship fixed in a tangible medium of expression. So when it comes to software, that's, it attaches as soon as you key the code. But let's not forget that, you can also protect schematics, drawings, and images, and those may also be valuable, licensable things. Firmware, this is also really software, and probably licensable, and publications like README files that may go along with your software. So that's, there's usually going to be copyright that goes along with your software.
So as a counterbalance, what's not a copyright? So copyright protects the expression of an idea, but it does not protect the idea itself. So copyright protection does not extend to ideas, procedures, processes, systems, methods of operation, concepts, principles, etc. I think it's important to remember that unlike a patent, a copyright protects, remember, the form of expression rather than the subject matter of the work itself. So even more importantly, for software, an author is the individual who actually captures the information in a tangible form, or in the form of software, is actually keying the code, not necessarily the person who had the idea of the code. Next.
Okay, so there are also different rights under copyright. Now with patents, recall, that's the rights are to make, use, and sell. With copyrights, those rights are to reproduce the work, to create derivative works, to distribute the work, to perform or display publicly. So they're not identical. So take, for instance, you have a license that includes both patents and copyrights. In the grant of that license, you're going to have more than just make, use, and sell. You're going to also have to dispose of, you're going to have to, do something with the rights under the copyrights as well. And so you've got really complementary rights here. You have more to do, more to use here. And to add more to this, and not to get too much into the weeds, it's getting harder to get software patents. Every few years, people like me will see something in the courts, Bilski v. Capos or Alice Corp. We'll see this, we'll watch very intently, we'll wonder, is software patentable? And we'll watch very intently, and then there will be an answer that's very unsatisfying, and we don't really know one way or another. And I think that the trend is that will continue, and it will continue to be somewhat ambiguous. And so that's really what we want to leave you with, is that perhaps patents aren't the way to go with software, but that's actually okay, that you have other options. Copyright is the first that we've talked to you about.
So patents are expensive. Software moves really fast. Is it really worth going through that? Well, one alternative, which I think will be increasingly valuable to us all, is what we call black boxing. And this is what's otherwise known as software as a service. It's what you get on your web-based cloud systems. And it's a delivery model that has some real advantages for the government, because we don't have to release the source code. We basically can allow people to use the system in the cloud and monetize it through licensing it. Somebody stands it up for us. Best example for this is you put in a zip code, you get your weather. You don't see the algorithms behind the weather.com channel, but you do get what you want. And if you're the New York Times and you want the weather report on your website, you pay the Weather Channel for that content. There are some FOIA implications as to whether or not all of that information that's in the cloud is available. Because we're licensing it to somebody else to serve it on our behalf, it's going to be up there either on a downloadable basis or a subscription model. What I especially like about black boxing, though, is that it allows for improvements over time. And learning systems in which the software is generating either data of its own or accumulating data from third parties really allows our software to be living and not static and dead, and it also allows customized versions of it to be available both inside the government and outside the government. Next slide. So we have a view of the world that's both ancient and new. In the biomedical software store that we've proposed, TEDCO has been kind enough to take the initiative with us. It still hasn't been stood up due to lack of government time and effort, but what we'd love to see is not only open source driving folks to the store in terms of freebies, sort of the giveaway section, but that apps, both free and paid, downloadable software, and probably most importantly for a lot of our research to research and embedded kind of software, are what we call APIs, where programmers would get pieces of code. But nothing's really precluded in this model. As a matter of fact, we had one licensee of our regular software that was patented say, hey, can we put a teaser version of our software in the store? Because although we concentrate on business-to-business transactions, actually having a business-to-consumer or business facing the public is something that we don't have the time and effort for, but we'd very much like to leverage. And so current software licensees would like this too. Next slide. One thing we have to move towards then is not just the licensing process and tech transfer, but the pre and the post licensing activities of what a software store could provide. And we have a lot of expertise within the government to accomplish that, things like security testing. But we also have limits of things we can do. So for instance, putting it into every major language that it's being picked up and used on, I think would be tremendously valuable. And keeping the community of users in touch with each other in the long run is another real benefit, both to us in trying to further the technology, but particularly in trying to get the software updated. Next slide.
All right, so thinking about how you can extract value from copyrightable materials and software in particular, especially if it's not something that you're traditionally allowed to patent. So first and foremost, it's important to remember that copyright protection for work for hires is 95 to 120 years. So that's an awfully long time, far longer than a patent, of course. Secondly, the rights of copyrightable materials are different than what you receive with a patent, but they're complementary. So if you have a patent around a piece of software, or let's say a method that a piece of software actually implements, then you actually have the software to which you can grant rights, and the two are complementary and serve as quite an appealing package to licensees. Then again, if you're just licensing software by itself, you have a much smaller cost of protection versus patent protection, and so it makes it a lot more reasonable and feasible to think about, multiple non-exclusive license agreements, which may make sense when you're trying to get something like an app out the door. You're not talking about a substantial major license with one particular individual or entity. And then, of course, the smaller capital outlay required for software makes management of the codes, I think, a more viable option in many cases where, again, it's not a more significant investment, whereas, patent decisions, once you're committed, you have a huge responsibility and sometimes a burden to get the technology out the door, whereas software commercialization is just not that much of a commitment. You can have a lot of opportunities that you're working on simultaneously. And then I think something worth noting before we go any further is that many times I've heard unfortunate stories of software and designs that have been obtained from the laboratory, and then the lab loses credit. And so you can actually use copyright protection to help preserve the credit of the laboratory behind the work that they've done. So it's always important to think about that, even if you're not considering commercial licensing of the tool that's been created. Next slide.
And before we go on, we do actually have a question. We have a question from Canon, wondering about how black box is different from trade secreting and whether GOCO labs are allowed to do black boxing.
So you can black box and publish if you want to, and that's frequently the case in the first generation of the product. Black boxing is basically just putting it up on a web server where people don't see the code itself, they just see the results of the code. So if it was a weather forecasting system, it would be a system that we would license to a commercial entity to make available. Once it's been licensed to a commercial entity, it does fall somewhat out of the FOIA box. If we're continuing to work on it as a program of record and somebody needs additional information about it, that's certainly something that would be for the lawyers to decide whether that data itself, particularly in the medical records arena, where we have a lot of HIPAA constraints. Once we've pushed it outside the firewall of the government, somebody else is going to be standing it up. A lot of times companies are looking for competitive code, and so they're going to want to get into the nuts and bolts of it. And the advantage of having it out there in the first place is that they can still click and ask to license the source code. So it's not mutually exclusive from traditional licensing, but the goal is to really make it available in as many forms as possible.
I think the question was for GOCOs. Was it contractor-operated facilities, Lauren?
Yes, that was a question about contractor-operated.
I'm not aware of any specific prohibition. I know that we had something similar to that at Oregon, where you could input some figures and it would output some results. In my mind, it doesn't differ considerably from distributing a piece of software in executable form only.
Right.
In that way, you're not really revealing the source code in any way. Now, it's important to keep in mind that we don't have any trade secrets. You know, we are obliged to publish anything, and we only have some short-term exceptions when we're, you know, filing for patent protection, and, you know, publishing something would establish a statutory bar for patenting. Other than that, we're not supposed to, you know, keep any trade secrets per se. We can protect trade secrets of partners, you know, company partners. But so I hope I've answered that question. If we haven't, we can maybe come back to it later. That be okay?
Next slide.
Okay, great.
So in addition to patents and black box and copyrights, trademarks provide great value. You could imagine if you had owned certain trademarks in the past that we let slip away as the government, things like Hummer. But our statutory authorities really differ. DOD was kind enough to pass a law that allowed trademark revenue to be used for tech transfer and the remainder to go to the warfighter. But most agencies, all the money from any trademark revenue would go right to Treasury. And that's something that should be unified across all federal laboratories. That really was not envisioned in the first place to be associated with trademarks with technology innovations. It was really trademarks for clothing and stuff like that. But if you do license a trademark associated with a patented or unpatented software invention, setting the royalty can be very difficult based on both the timing, the value of the mark, and what happens over age. And I won't belabor the specifics that are here, but considering the inventors of a patented technology really want to see the revenue stream come their way, the trademark always takes a back seat unless for some reason it was really important mark. Next.
I would like to add that trademarks are commonly used to protect open source software. A great example would be Linux and Red Hat's version of Linux. We do something similar here at Fermilab with something called Scientific Linux. The idea is that while a copyright can be released as open source, the trademark can still be protected. And so as a result, you know, even though the Linux operating system should be free under the terms of the open source software license, people cannot arbitrarily use the trademark. They can, and so that can sort of distinguish between open source software that was obtained from the open source community versus a version that was obtained from the laboratory. And that's something else that we could discuss in greater detail if it's of interest to the community.
So we do have one question about trademarking. Specifically, Inidia would like to know how you police the use of the trademark, I guess if people are violating the policy.
Well, so that is the rub. The rub is this, is that if you do have a trademark, you are obliged to enforce it. And so a laboratory might find itself in the awkward position of having to send enforcement letters. And most laboratories don't want to be the big bad government laboratory saying you cannot use that So generally speaking, my recommendation is not to launch headlong into filing for registering their trademarks. It would be first to use your trademark as a real trademark, as a common law trademark, which is really the requirement anyway to be using it properly. So recommend to your PIs that they use it appropriately. And after some time, if they are using it consistently and appropriately, then you may find it useful to actually file in the various jurisdictions. And there are many jurisdictions, and there's, it's its own, it takes some, you'll have to find, competent counsel to do trademarks and things like that. So yes, it can be awkward.
Well, I think
go ahead, Kathleen.
Go ahead, Barry. Oh, well, in certain labs actually choose to use outside counsel for enforcement purposes. Of course, that can get expensive. So I think the bottom line is what Aaron already pointed out, is that you have to be very deliberate and intentional about those things that you choose to pursue trademark protection on. It shouldn't be everything. But Barry, actually, you probably have the most experience in this world, given the Army's extensive use of trademarking.
It's really important to get the trademark established early, because the goodwill associated with the mark is really what our licensees are after. And if we wait until the day we're about to license it, that's not going to work. There's no goodwill yet associated. But considering the time lag from start of project to preliminary products to final licensing, there's plenty of public presentations and conferences and papers that are great opportunities both to build the brand and really to give the recognition to the inventors, because it's great to have a publication, but it's also great to have a product, even if it includes your name, perhaps.
Well, cool. So that was a good discussion. Moving on, building user communities is something of value, a non-monetary value that you should think about. Building user groups can relieve your PIs who may be software developers, or may not, they may be de facto software developers who find themselves having to maintain a piece of software but have other mission duties. And so open source software release can be a way to leverage the power of the crowd to help do that, to find bug fixes, to help maintain a code, to help build the reputation of what may be a small group at the laboratory. So these things, it can help to keep that in mind. And oftentimes, even building a message board to help in troubleshooting can be very useful to your PI. It's something to think about.
Along those lines, I'd really like to advocate for communities of practice and a system in particular to be stood up by somebody for us to all use, so we don't have to build them all by ourselves. I think the FLC would be a wonderful partner in such a project. And there's a real difference between a community of interest and a community of practitioners. So let's say we license a training system for OBGYN, like we did with one of our inventions out of Madigan. Your active nursing staff, medics, physicians are practitioners. And if they're using your software, they all have gripes and suggestions and good things. And what we really want to do is facilitate them sharing those. They could be white papers, they could be presentations, they can just be an approach to a problem that somebody has had. Being able to have some input into that community of practice can be facilitated actually through the license. Next slide. So if, for instance, the licensee of your technology pays an annual fee to host, in essence, or sponsor, rather, a community of practice, this is going to positively impact the product in the marketplace, and in particular offer the company the best tool possible to keep it improving, and that is being able to solicit, not every day, because that would get pretty annoying, but X times a year or an annual contest. These would be great ways to not only keep the licensee's product in the mind's eye of the community of practice members, but also the role of the originating government lab, where those folks can be looked at as sort of Delphi guru kind of status. Next slide. But in order to do this, we actually need a backbone, and there is no shared cloud space that's been made available to us yet. There is an organization called NSTA, the National Security Technology Accelerator, that I'm hoping would be interested in such a project. But why not really set up a system to help us connect not only with our licensees, but with our community of practitioners, because many of our inventors are actual practitioners in the field. They're not just research scientists. They're doing stuff that is clinically related, and hence a real opportunity is at hand. In order to do it well, we have to be able to standardize what's being pushed around and come up with a schema for that. Next slide.
So one of the things that is really important to remember that I think we're trying to emphasize in a number of ways is the unique value that you can get from software, copyrightable materials, as we've mentioned. And so we wanted to throw in a couple of specific examples from two different laboratories that both Aaron and I are familiar with. In each of these instances, the programs from where the software was developed actually used the notoriety that came from the tool that came out of the program to further expand their presence with the program sponsor. And we did that here at Los Alamos with MCMP, who many of you may have heard of. It's a Monte Carlo simulation code that's got over 13,000 licenses worldwide. And then Argonne did just much the same thing with MPitch, with implementation of their message passing interface, which is the most popular version of MPI around today. So it's really not necessarily in those two cases been about any type of revenue, because there hasn't been. It's all been about recognition directly back to the laboratory for their contributions in those specific areas. Next slide.
Yeah, Argonne's MPitch, they got an R&D 100 award for that. It's paid, continuing dividends, non-monetary, but, additional follow-on sponsorship of, programs. In a lot of ways, it's, kind of priceless. So really, and I didn't have the figure for a number of downloads, but, several thousand, comparable to MCNP.
All right, so something we need to be aware of when we're talking about copyright and software is what I like to refer to as stranded assets. It's really something to pay attention to, because it can really trip you up in the back end when you're trying to get a deal put together. So let's talk about what they are first. Stranded assets are actually created under subcontracts, typically with universities, in some rare cases with commercial entities, when they're doing work with the U.S. government. What happens is these materials are typically created as copyrighted materials, usually software, sometimes drawings, and the subcontract fine print, unfortunately, as it relates to data rights, dictates ownership and rights back to the individual or entity that created the work. So the U.S. government retains the right to use the material created, but we don't have the right to own it because the government can't hold title to copyright. So you end up with a piece of copyrightable software that a university may have created that we may want to subsequently license as part of a larger package, but I don't have rights to do so because the data rights gave that ownership right to the university upon creation of that material. So that gets to why we care. It obviously has a significant impact upon some intellectual property portfolios that are, in play as far as licensable, because it limits my ability to license them until I clean up ownership and commercial rights associated with that code. And then, of course, so lack of clear title creates a stranded asset. Next slide. So what can I do? So there's a couple of approaches that you can take to overcome the unclaimed copyrightable asset that I'm referring to as a stranded asset. The first would be modifying the data rights provisions in your subcontract. This is probably not a very popular solution because it is quite difficult, because you're actually talking about modifying special terms and conditions in the subcontract, which are otherwise dictated by the FARs and the DEER. So not an ideal solution, but it has been done in a couple of cases. The other option would be working directly with the subcontractor who created the work, seeking either assignment of title, royalty sharing agreement, or other type of arrangement. But of course, preferable would be doing this up front as opposed to the 11th hour when you're about to sign a license agreement with a commercial entity and you come upon the fact that, oh, there's a third party that has rights involved that you didn't know about. Challenges, of course, are simple ones. Even just getting a disclosure from the third party, like the university who created the code, can sometimes be hard. And then also there's additional time to negotiate the agreement with the university or subcontractor who created the work that you may not have originally planned on. So it adds to your deal stream, or your deal flow timing. So switching gears again about what we can do at a GOCO that you can't do at a GOGO, and vice versa. So we're all familiar with contractor-operated laboratories versus government-operated laboratories. For the purpose of this webinar, the primary distinction is contractor-operated laboratories have the ability to assert copyright or elect title to a copyright, in which case we can then subsequently license copyrightable materials in accordance with the prime contracts that we have, at least at DOE laboratories. DOE specifies that for us. GOGOs have other options, which some of them you've heard about from Barry directly. So the U.S. government does not assert copyright in works created under official duties of employees. The interesting thing, though, is that they can actually accept an assignment from third parties, which I know certain GOGO laboratories are doing experimentally to see if they can capture and leverage assets in a different way. Excuse me. Contractors or GOCO laboratories can assert copyright, as I mentioned, and this is particularly relevant for commercialization strategies. We can also, as contractors, assign copyright to another government entity or to the government, and so that's useful and beneficial. Now, the one interesting thing which we haven't heard that much about from the respective agencies, but is pretty neat, is the 2014 Defense Authorization Act actually specifies that DoD and its respective agencies can license software commercially, even collect royalties. We haven't heard a whole lot about the regulations for implementing the act, but it's quite a major step as far as enabling DoD to monetize the software that comes out of the DoD laboratories. So with that, next slide.
Thanks, Kathleen. In particular on the DoD side, we've licensed software previously, but one of the challenges has always been, does it really rise to patentability to be an invention under Stephenson-Wadler? And the benefit of the legislation was to say, hey, not everything has to be patentable in order to be valuable and rewardable, which is the intent certainly implied in Stephenson-Wadler for our inventors. But just rewarding the developers is an important component in software commercialization, even if we don't go forward and file a patent. I think it's important to not force labs into making pretend that they have an invention that's just a little piece of code that's a widget, and yet that widget could be of tremendous value, maybe at 99 cents times 100,000 people, not necessarily for a patent that costs $15,000 to file.
And Barry, just as
yep.
I wanted just to throw in, because I've heard you say that from DoD and lots of other folks say that from DoD, and I'm hoping that that's the general shift in consensus, because when you think about, as you mentioned, $15,000 per patent application, when you're really trying to force something into a patent that really doesn't rise to the level of a patent, there should be an alternative mechanism to protect and convey rights. So really reiterating what you're talking about, that it's a logical step as far as what the Defense Authorization Act, I think, is targeting.
And that really fits well with the current slide, which is, do we need to change the way we commercialize software? And I believe the answer is yes. Historically, just giving it away is fine for open source, but not always. If the project requires support past the originators of that code, who's going to pay for that? in the open source world, we have plenty of dead on the vine source code projects that just don't keep going because the originators have moved on. There's also a lot of uncertainty about how to price stuff in the cloud. We're so used to our traditional patent reimbursements and milestone payments and all that kind of stuff that to move to an app-based model, what we really have to do is move to a commercial model, which is let the marketplace decide and have variable pricing. We may, for instance, have one price for government downloads and or utilization and another price for industrial. But we have to start getting more commercial in our thinking in regards to valuation. Next slide.
So before we move
Barry,
on, we do have Sorry, go ahead, Aaron.
Go ahead. No, go ahead, Lauren.
We have a question that's come in from Michael. He's wondering about whether the government has to offer further consideration to a contractor for assigning copyrights above and beyond their contract to make the software for government use, if you have any experience with that.
So yeah, we do have a tremendous number of data rights situations that occur because some of this software is developed solely by the government employees, solely by contractor employees under very different contracts, and sometimes co-invention. And the commingling, as both Lauren and Aaron, or Kathleen and Aaron have indicated, can get complicated fast as you're working frequently on group projects. So it's important for the data rights to be thought through before you have a contract, but we all know that doesn't actually happen because a lot of the contracts are just head shop, stub shop folk who are staffing the labs with individuals who do have copyrights that are de facto created as non-government employees. The challenge is to get those back. They can assign those rights to the federal government, and it's not uncommon for us to ask for that assignment in the same way that we frequently ask for the assignment of other intellectual property rights, such as patent rights on inventions. What we traditionally do is treat the inventor the same, whether they're a civilian or a contractor, and that generally is incentive enough for their contract shop go ahead. We occasionally have had challenges where nobody wants to sign anything and it just goes forward commercially, and that becomes problematic if there were litigation or additional companies that wanted to access it.
Right. I'll just add that hopefully the appropriate data rights clauses have been added to the procurement contract. And if you work closely with your PIs, you can let them know to, be cognizant of that when they're actually, having, if they're requesting anything that will involve production of data. But I did want to add before we move on that that's, I know that I and Kathleen, we've both, Barry mentioned that sometimes you can have a piece of software in the open source and it just dies anyway. Nobody's paying attention to it. And that's a good reason to think about perhaps doing a partially exclusive license for a nominal fee if the actual benefit coming back to the laboratory is a company maintaining that code, making sure that it's up to date and works with the new operating systems and things like that. That can be a tremendous benefit. And your PIs can get the benefit of, using a code that's still maintained and useful. So with that, let's move along.
So I'd like to make the point that perhaps we in the tech transfer world shouldn't really be doing software licenses the old-fashioned way. We have to get out of the way. I love disintermediation as a phrase because an app store totally disintermediated all the other stores. iTunes disintermediated Sam Goody. And the reason people like it is they get what they want quickly. Now, we may need legislative changes to allow, in essence, that kind of sub-license to occur to an end user without an application to do so through standard tech transfer channels. It's the reason we also can't host the store ourselves and have to have a third party hosting it for us as a licensee. But one of the cool things is that all of our developers could potentially benefit from the standardization that having a software store would enable. Having similar splash screens, that they don't have to recreate menuing systems, etc. And that reuse may well lead to more enterprise valuable connected apps. It certainly would be easier for the end user. And then in today's world, we have a very large group of folks who are interested in improving it for their own use as well as for what other people could benefit. And having a distributed workforce is tappable. We've seen this in the online world, 1,000 Ways to Sunday, but really integrating that into a government-created piece of software, I think, will be very important. And lastly, we've really got to get off the desktop and not just onto a phone, but tablet as well as the desktop back again. Thanks.
Okay, so what might some of your software licenses look like? You might use an end-user license agreement. So this is good for multiple non-exclusive licensing of a piece of software direct to the end user, the person who's actually going to load this onto their machine and use that piece of software. Typically, when I do something like that, I'll have various price points for a lot of reasons. Typically, this is a piece of scientific software for some type of modeling. It could be a multi-physics code. It could model some type of manufacturing scenario. And so it might be useful both in academia and in industry. Okay, there are people studying this situation, plus there are people actually using it in that same situation. So in academia, they may have a lower ability to pay, but they're also not using it in that situation, so they don't necessarily need all the strong indemnity and arbitration and things like that. Plus, we want people to train on that piece of software. We want people to publish and use it for their research and perhaps even further develop the code. So make perhaps a lower price point for academia with the right to publish around it. Industry, a much more robust license agreement with commensurate consideration for that license agreement. The foreign license agreement, perhaps more expensive than the domestic one, so that we're showing preference for U.S. Enterprises. And this situation is suitable for perhaps high demand volume licensing. It actually makes more sense. You can do multiples of these if you can set it up, have a website that even talks about the various price points, and you can discourage negotiation of the language in those licenses by having a model agreement there. Say, sign the agreement, send it back to me. Anything you can do to sort of discourage the amount of time that you spend on each one, usually helps you out. And these are typically done in executable form only. Now, we really haven't talked that much about that in this webinar, but executable form is, typically the ones and zeros. It's the way that this is your computer reading the software. Source code is how a person actually writes the software. So that's usually human readable code. Okay, executable is much more difficult for a human to read, although not impossible. But that's typically how it would be distributed, although not unheard of. You can distribute code in source code form to end users, but it's not an ideal situation. Now, with commercial licensing to distributors, it'll be a little different. What you'd like to do is distribute to a company that is equipped to actually sell software en masse. So as a result, your license is going to have sub-licensing rights. Okay, you're typically going to convey source code to that company so that they can maintain the code, make sure that it works with various operating systems, you know, and things like that. It really relieves the burden of executing numerous license agreements, okay? And in exchange for that, you'll probably get either a quarterly report or maybe a yearly report, and you'll take a cut of the, you know, you'll take a royalty. A lot of times what you can do is you can start out by doing end user license agreements, and if you find that your piece of software is very popular, then you can do a call for commercialization plans and seek a software distributor. And the agreement would be that, you know, if you do settle on a distributor, you will no longer grant, you know, license agreements to end users. And you can be very open that there are licenses out there, but you'll go with a commercial software distributor from now on. And that's sort of a typical pipeline for software, if you will. So you can also do this on a non-commercial basis in cases where, you know, maybe export control is an issue. So export control in itself could be an entire webinar. You could do an entire session on export control. You may not want everybody to have your software. You may, you know, actually want to have visibility on who exactly is interested in your software. It could be, you could have some type of modeling software that could be useful in a number of different engineering scenarios. You're interested in what the most useful or interesting engineering scenarios are. So actually having individuals approach your laboratory for the license could give you some insight into what those applications are. And so simply throwing it out to the open source community or you know, going with a distributor may not give you that visibility that you desire. So, you know, controlling it in a way gives you a lot of information that you may want to have access to.
So Erin, before we move on, we do have a question that's coming from Jialing. I think specifically Jialing wants to know more about what kind of language should be used when talking about data rights, I think in agreements and such.
Okay, data rights will typically be in your procurement if you're procuring assistance in actually developing the software itself. Now in your license agreement, you're typically going to grant the rights that I discussed earlier in the webinar, such as, you know, the right to create derivative works, perhaps. Now, the right to create derivative works, you won't grant that if you're only conveying executable code. Say if you're granting only executable code to the end user, you don't need to give them the right to create derivative works. But if you're you know, licensing to a software distributor, they probably do need the right to create derivative works because they may even rewrite the software. Say you wrote a piece, say your code is written in Fortran, they may need to rewrite that entirely. They may need to write it in C or, you know, Java if they want to create a software as a service, as Barry's been talking about. So really, you know, for something like licensing to a distributor, that's more of a business discussion, a longer, you know, more strategic discussion. Whereas end user license agreements, you can sort of decide that ahead of time, but not so much a data rights provision. Am I in the right? Am I answering that properly, Barry and Kathleen? Am I understanding that question?
I think so. It's really two different things. There's the data rights provisions you need for your procurements versus the, you know, the forward rights granted under a license agreement.
So I think
yeah.
I think Jialing's specifically looking for like specific license or language examples. So I'm wondering if maybe that's the kind of thing you might want to connect offline about. I don't know if we have any specific examples coming up in the next few minutes.
If we have some time, maybe we can discuss it in greater detail or get some additional text and perhaps discuss it. I know that, so the data rights, so that's a federal acquisition rights or rights in data general clause. for 52.227 something, and then there's a special work clause if you're intending for somebody to develop data. But then there are agency-specific clauses, like Department of Energy has DEERS, that's the Department of Energy Acquisition Regs, and it's going to be different depending on where you're from. So, but again, those are for your procurements, and when you're licensing, you're typically going to license rights under either copyright or patent or, you know, trademark. There are different rights. So, you know, it's going to be, it's going to differ considerably. But yeah, we'll come back around to it if we have additional time. Let's see here. Okay, open source software. So, oh, was this, are we to Kathleen now?
Yep, it's back to me. So this is, again, is another topic that could have an entire webinar of its own. So we're just going to give you a smattering of information about this. And again, it's something we could cover more in questions as needed. I think the takeaways related to open source for practical implementation are remembering, first and foremost, that there are tons and tons of open source licenses out there. I think another thing to remember is that depending upon which agency you work for, you have different requirements associated with open source and how you go through the process of releasing something as open source. So that's something else to keep in mind. Along the lines of the license types, you want to pay attention when you're thinking about releasing something an open source license, because if you want to tightly control how future things are made related to or developed from your code, you would want to use a more hereditary or viral license. Whereas if you don't care what people end up doing with what you create, and you, for example, you don't mind if they put it in a commercial product, you don't care if they end up you know, grabbing a copy and doing something with it that you have very little control over as far as licensing goes forward, then you would want a very permissive license. So at the bottom of the slide, you'll see a couple of examples of permissive versus protective licenses, and there are many, many others across the spectrum. A resource that's useful is the Free Software Foundation's website, which they actually have approved licenses that they recommend for open source release of tools. So looking at the next slide, we can talk a little bit more about how we go about thinking about open source, and I would also point you to the handout for the webinar, which has more information on open source licenses as well. I think critical to remember here is when thinking about when you want to release something as open source, first and foremost, if your researchers have developed a piece of software that you want to then further distribute, have they used anything that was covered by an open source license? And if so, what software license was it covered by? Because there will be implications. And then also, are there reach-through license requirements associated with the compiler that the entity is or that your researcher is using? In many cases, you can overcome this by just telling someone who is going to receive your code where to go get a compiler or to use a different one. But it's always important to ask, because you don't want to unintentionally infect your code that you release by using a virally licensed compiler. Something else to keep in mind is there are more and more multi-lab collaborations, and across, these are very, very popular within DOE currently, and they're also incorporating other agencies. And so there are considerations that you need to think about when looking at open source software or even closed source software development across GOGOs and GOCOs, and that's something we can certainly answer questions about offline. Usually there's an attempt to put an IP management plan in place in those cases, certainly to address some of these issues up front, but a lot of times the tech transfer folks don't get the notification about the multi-party arrangement until after it's already well into its research and development cycle, so there's a little bit of catch-up that sometimes has to be done. Other options are thinking about roles for partnership intermediaries associated with open source, which Barry has experience with, and then also very important to think about when looking at open source whether or not there's related patents, because different open source licenses have specific explicit or lesser implicit patent grants that you have to be mindful of when thinking about your open source licensing strategy. So next slide.
This fourth box here, I want to note that a compiler actually changes source code into executable code. And paradoxically, some of the open source compilers are actually okay to use, whereas some of the proprietary compilers will actually have reach-through license requirements that require you to execute a license in order to distribute your own code. So it's important to ask your PIs what kind of compiler they did use.
Right. So I'll quickly cover this next slide because I know we're starting to run short on time. The long and short of this slide is that you see in the columns at the top, permissive, weakly protective, strongly protective, and network protective. These are various examples of licenses that fall under each of those domains. So for example, you've got MIT license listed, you've got the BSD license, you've got Apache. Those are all within the permissive domain. Then you've got weakly protective open source licenses, various versions of LGPL and MPL. Strongly protective license types in the open source would include any of the varieties of GPL, and then a network protective license would be the Affero GPL. The point of the slide is that when you start to mix and match pieces of code, you really create a bit of a puzzle for yourself that you have to navigate so you can determine whether or not the licenses that are coming from the different pieces of code you're putting together as a new derivative work are actually compatible. So I think it's really important to actually look at those details before you get yourself in a quandary where you release something under a license that you think is permissible, but it's not because the licenses that are actually inside the tool that you're, that you're leveraging are incompatible. So anyway, I think with that we should. Oh, go ahead, Aaron.
Yeah, what I like to say is there are actually thousands of licenses. This is a small subset, just to simplify. If you had Apache 2.0 and LGPL version 2.1, in order to combine them, they could only be released as LGPL version 3 or above in this diagram. They couldn't be released as, say, BSD new. And so that you can see that if you had 3 pieces of software or 10 pieces of software, which is very common, you may not be able to release that software at all. Those pieces of software may not be releasable because they have contrary licenses attached to them. So here's a slide that actually has some incompatible licenses, and I chose these because you may be familiar. For example, NASA open source agreement. You may actually be interacting with somebody may poach a piece of code from NASA, and it can't be mixed with the GNU GPL license. And GPL is a very common open source license. Same with Apache license version 2.0. Yahoo is less common these days, but this does happen, and this is just a combination of two licenses. And Kathleen and I have worked on code bases that include 20, 100 different pieces of software. So this is a common occurrence. And the best you can do is, just take a list of what's in your code. And if it is going to be a high value license agreement, there are commercial entities that will help you take stock of what's in your code base. And I could recommend some of those. That could be the subject of another webinar. And yeah, go ahead. This could be, SaaS can actually help in cases where software may be non-distributable as a combination work. And that's a question that, I'd like to maybe posit to the group.
So lastly, there's a lot more because we're moving to the cloud with inventions that are strange intellectual property, like what's the spec for a new nose, new ear, that's going to be printed remotely by somebody who needs one? Well, how do we're not going to patent each one. We may have some patented software associated with creating the most aesthetic ear possible. But digital rights management for 3D printing is very much coming down the road. The Europeans are doing it so that parts for machines can, instead of being shipped, be instantly printed at remote locations. And when you think about it, it's not that different than the copy Kinko kind of model of the old world, where we don't need scribes anymore, but we don't even need FedEx anymore if you can just email it to a remote printer. But who controls that? How many times can they print it? How do you monetize it? We're going to see software develop into many areas that are going to truly be both unique and enjoyable, and even if smaller dollar amounts per transaction, potentially larger if there was a big hit because a lot of people wanted it. And when you think about it in the long run, having something where a lot of people have access to a government-invented widget is exactly what we should be aiming to do. And exclusive patent licensing has made it somewhat difficult to do in a way. I'll end there. Kathleen, Aaron, any closing comments?
None for me.
No,
Just thank you everybody for joining.
Yes, so we do have... Sorry, go ahead, Aaron.
Just to send us your requests for additional, additional topics, interests, questions, and we hope to see you at the 2016 national meeting.
Yeah, we do have a couple of questions if you guys have a couple of minutes, but before we get to them, I just want to, in case people have to drop off, give them a couple of things. Obviously, these folks are going to follow up with another session at the national meeting. That session will be on April 27th. You can see the registration link on the slide here. I believe you have about 3 more days to register at the early bird rate, so if you're thinking of going, that's probably a really good time to do that is right now. So that's the main thing. Also, in case anyone would like to come back to this, email me if you want a copy of the slides. We'll also be putting the webinar up on YouTube, and we'll also be sending you out some badges just to share online your participation today. So Aaron and Kathleen and Barry, if you do have a couple of minutes, anyone who has asked a question, if we want to get to those, certainly we can give that a shot, even though we're at our official end time if you have a few minutes for those.
Sure.
Okay, great. We have a question from Jeanette and a question from Phoebe. So I'll get to Phoebe's question. First, she'd like to know if you could provide an example of how a call for a commercialization plan might work, and is it like a broad agency announcement?
So I'm actually doing a couple of them right now for software. We're doing them they're couched in terms of, one is a request for information because it's more general, and one is actually a request for proposal. So couched a little bit in terms what a lot of people are familiar with regarding procurement, but the language of the call itself is very much oriented towards software commercialization. So that's the way they're framed for my laboratory, but they look very similar to what I would have as far as a call for commercialization for patent as well. And in both cases, I'm looking for a third party to distribute that software. And one of them has patent rights and one of them does not.
Okay, was there anything that Aaron or Barry you wanted to add to that?
I've done a few on... Yeah, go ahead.
Just to say, depending upon how the relationship is coming in to the government, either in a creator relationship, an SBIR, just a invention scenario where we're working on things informally, there are a lot of opportunities for us to take the next step more formally and sort of backtrack and cover who has the rights to do what with what. And the meeting of the minds there is always better done sooner. In formal solicitations under the BAAs and other government contract programs, those data rights are a little bit harder to be flexible on, whereas in a CRADA and a license scenario, we can cross-license our partners in any number of ways, provide background intellectual property, provide future activities, and it really just depends on the nature of the beast. And there are plenty of folks who have been there and done that. And so if you have specific examples that you need feedback on, the FLC meeting is a great place to be able to ask your specifics.
Okay, anything from Aaron as well, or?
I've done a few on Fed BizOps. just request a commercialization plan, that sort of thing. Sometimes I'll put a template and see what comes back. That's usually pretty helpful.
Okay, great. And we have one question as well from Jeanette. How often is the code audited for license types, and who performs that type of audit?
So,
Aaron, I think you have the most experience in that.
Yeah, there are a few companies that will do that. One of the companies is called Black Duck, and what they do is they will take your code base and they'll fingerprint it, and then they'll cross-check it against a database. Well, it's like a fingerprint that they have of a whole host of open source projects that they have. And then they'll produce a bill of materials of your code base, and if they see matches against any open source projects. And it can be expensive. Black Duck is not the only company that does this. There are a few others, and then there's an open source company that does it as well. But they don't have the open source version relies on you to have a code base to cross-check against. So like HP, I think, uses the open source version because they have their own database of open source projects. At any rate, there will be a few occasions where you might have a large deal looming, and so it will make sense for you to pay to have a company do that. And I think as a laboratory, we got a discount or something, and it was worth doing for peace of mind. There were a couple of, pieces of the code that we were able to address, remediate. As you might imagine, there are, over time, a piece of code will have vestigial portions that aren't even being read anymore, pieces of code that someone started to develop, but then the project took a different path, and so that part isn't even being used. And so various parts can be removed, but they simply aren't. And so I think in that case we did remediate some of the code, and it was helpful. But what tends to be the case usually is that you just work with the PIs and they tell you what's in there, and that's just the best you can do. Obviously that's not very satisfying, because if they're working with a group of people, those other people can knowingly or unknowingly introduce other pieces of code, and there'd be no way of finding it. But yeah, it's sort of a business decision whether or not to go with a commercial company to do that. But there, like I said, there was the one company that I just told you about, and I can't off the top of my head remember the others, but if you follow up with me, I could probably dig that out and provide it.
Okay, great. So it's all the questions that we received in advance just now. So if anyone has anything before we drop off, feel free to type it really quickly. Otherwise, just let us know anything more that you want to know, or any feedback about how we did in the survey that appears as you leave. But if you do have any questions, feel free to type a couple more in now. Otherwise, we'll give you just a minute. And otherwise, we hope we'll see you next month in Chicago, and that you have a great rest of your day.
Thank you all.
Yes, thank you.
Thanks, everybody.